Hello, good day to everybody. Welcome to Connection Wednesday's webinar, a regular webinar of IDEA StatiCa. Today is October 3rd, and so there is another series of Connection Wednesdays. And today we'll focus on BIM links of IDEA StatiCa with other software, with SAP2000 and Advanced Steel, and show you a nice example. For today, my faithful colleague Jana is missing. She's on the IDEA StatiCa User Day in London, working on her duty there. So for today, it's just me, Adam, and another skilled colleague, Veet. So that's for who's presenting today. And another practical info, you are muted by default in the GoToWebinar. And if you have any questions or comments, please use the question panel and just feel free to ask anything that comes into your mind. We will try to answer all the questions during the webinar. If we won't have enough time for that, we'll get the answers later by email. So, what are you going to see today? Veet is going to show you this project. It's a steel hall. We got it in a SAP2000, so a structure model of the steel hall, and we got a drawing model in Advanced Steel, and we're going to merge these two models into IDEA StatiCa. So that will be the easiest way how to get a joint, complete data and information of a joint from these two softwares into IDEA StatiCa and code check them just by one click. So that's one thing. And the other thing that I will talk about is about the load effects, the distributions and settings, and some tricks and things behind that. So that would need some concentration. But first, let's start with the show of Veet. So I'm going to give the presenter to Veet, and he's going to show you this BIM merge.
Hello again to all attendees. I'm very glad to be here today. I prepared for you quite a nice example. So let's just start in SAP2000. You can see it on your right side of the screen. We have a really nice steel hall, an easy example, and we can start right away. So I have to run analysis first to have all results available, and I have IDEA StatiCa connection plugin already installed. So I just open it, and now let's start with one connection. Okay, I have to choose it first, no problem. And now you can see that the progress bar is at the bottom of this window. In a minute, IDEA StatiCa connection window will automatically appear. Oh, here it is. The wizard is now running, so let's just click through it. We can see we have all combinations, load cases, and everything is set. Just finish, and in a second the project is generated. Oh, here it is. As you can see, we have members with cross sections and imported load effects, which is quite important because we will import these load effects to advanced steel exported projects. Now I will close this because I don't need it anymore. And let's jump right into the advanced steel. Now you can see that we here in this project we define the whole structure with members and connection entities, plates, welds, bolts, the whole connections. So we have our structural model, and let's take advantage of it. With the code check manager, you are now available. You can now import the connection in an easy way, only once, like you are used to in the previous versions. That's not changed. In the past, we had to input the load effects manually, but not anymore. We can combine exported projects from SAP2000, for example, with this project from Advanced Steel. And how we can use this feature, connection import. And I will find my exported project from SAP2000, this one. Just open it, and the load effects will automatically appear at the right members. Now we imported both combinations with internal forces, which is great. I don't need to input anything manually. I can start the analysis right away. We saved the time by connecting these two projects. Okay, I design it, I imported loads, I check it, it's okay. Let's continue. Just close it, and in the code check manager, the new project item will appear, and here are information about the results, about the members, and about the project which is connected to this project item. Also, the model gives me information about which part of the model is imported, this joint and these three members. Okay, so what if I need to change something? For example, in SAP2000, in the loads. Okay, no problem. I will close this and I will go back to SAP2000, and I will just increase, for example, loads. So just give me a second, unlock the model, and change the loads a little bit. I will change the permanent load, and for example, I will increase the uniform load on these two beams. On this one and on this one. 15, okay, apply, great. We increase the load. Now we have to recalculate the project again. Great, we have results. Okay, let's turn on the IDEA StatiCa connection plugin, code check manager, choose synchronize function. At the background, the whole process was performed again, and I can only jump right into the project I don't need to do anything again manually. Great, and you can see I have almost 55 kilonewtons in the column. So that's the change. And now how to get it into the advanced steel exported project. Let's close it. Jump into the advanced steel to on your left side of the window. Launch Connection Code Check Manager. And now with one button, synchronize the project. The new load effects from SAP2000 is synchronized with this exported project from Advanced Steel. That's nice. You can see here that we have almost the same, it's not almost the same, it's the same value, but almost 55 kilonewtons in the pressure in the column, which is great. So I can calculate it again. And without any problems, without any manual input, I combined these two models. Great. Just save it and go back. And I want to do another joint, for example, another one into another code to show you another possibilities. So let's again open the Code Check Manager, and let's say we want to export to American code. Okay. Now I will choose the right node with right members, export it to American code, and in a while the wizard will be available. Great. Let's proceed. And the project is loaded. Again, I have members, cross sections, and load effects. Okay, I will close it. I don't want to do this here. I want to use it on my structural model. So let's continue here. Code Check Manager, and I will export another connection from Advanced Steel. Great, we already have it. Now let's import the load effects from SAP2000 exported project again. This was the joint 6, the new one. You can see it here. Okay, import. Great, we have it all. We have it all here. So let's just start analysis, and we are fine and finish. And you can see that our bolt is not past the code check. Okay, so I will save it, close it, and I will show you some other features in the Code Check Manager. As you can see, I can have here a lot of project items. It depends only on you. how many of them you can export and you will use. And on the right side, you can see information about exported project, overall status, if it passed the code check or not, some summary of results. You can see here the picture that you can realize which one it is, and you can see all other information about the code, information about the project, about the creation time, etc. And I think Adam will talk with you about these all new stuff like calculate and calculate all and modify in some other Connection Wednesday webinar. That's all from my side, and I will ask Adam for the continuing.
Sure. Thanks, Meet, for interesting example. Sure, I will talk about it more in a later Connection Wednesday webinar. As you could see, this is a new feature that's actually hasn't been released. It's going to be released in 1 or 2 weeks as a new upgrade of IDEA StatiCa 9.1. So this is waiting for you. This was just a small taste of the new features, but I believe we can all see the potential of this new feature, how you can merge BIM links to get even more effective workflow. And I'll take the screen. And we're just working on it quite a lot because we really see that this is the future of engineers' work and the workflow. As you could see, just by a few clicks, you get the whole joint, all design, all combinations into IDEA StatiCa, and just calculate it and get the results in a few minutes. So with any topology, any loading, of course. So I think that looks promising. So what I will discuss today with you is the load effects or internal forces, because we had quite some questions on HelpDesk on this topic, as well as some questions from previous Connection Wednesdays webinar. So yeah, let's make this a bit more clear. I have this example. This is actually the joint that we exported from Advanced Deal with the loads from SAP2000. So what we can see, just the joint here, the load effects, everything looks okay. But there was a question, where are actually the forces applied? So if you open any model in IDEA StatiCa, you get this, by default, this solid view, right? And you see the forces at the ends of the beams. But in fact, these load effects are nothing else than the internal forces in the node of your structure model, right? So they are not at the end of these beams here, but if you switch to wireframe, I would show you the structure model, just the beams and the node, which is this black ball. That's the node. And then now you can see that those internal forces were moved to the node, and that is the right position where they actually lies and from where they are calculated with or analyzed with over the joint. So yeah, so this is just to, you know, better display of to which beam the internal forces are applied on or yeah, depend to. So but the reality is this one. Yeah, so the wireframe display. So that's one thing. So it's always one basic information is very essential. What you have here, all these forces, those are nodal forces from the structure model and are applied in the node. Yeah. So what else can we explain here? Well, probably switch to another model. Or I can stay in this one maybe. If I click on the forces here, I can see the moment distribution along the member, right? So it starts at the node and it's rising downwards along this beam. If I switch to another combination, I can see the same, just a different value. Yeah? So what is this? This is actually a simplification, because what you import into IDEA StatiCa are nodal internal forces, right? Not the loads on the beam, the outside. So what you have here, the distribution of the moment is calculated based on the moment value, which is 6.1 at the node, minus shear force multiplied by distance from the node. Yeah. So this value minus 12.6 is somewhere at this distance from the node. And this is of course simplification, because it's just a simple linear calculation of the moment value, but that is not what we are interested in IDEA StatiCa, because what we do, we of course focus on this very proximity of the node, of the joint, right? Because what we do in IDEA StatiCa, we don't calculate the overall model, we code-check the connection items. Yeah, we code-check the welds, bolts here, and those are so much close to the node and to the actual nodal internal forces that we apply from our structure model, like from SAP2000, for example, that this simplification of this linear moment distribution doesn't really affect anyhow the analysis and the results. So that was the explanation of the moment distribution and these numbers here. And the third thing I would like to discuss is from the previous Connection Wednesday webinar, we had this interesting example of a curved arch, and I have to confess, I did a mistake, and thanks to one of our users and attendees of this webinar, Camille, who told me about this, and I haven't noticed, I made a mistake in the internal forces application here. So what I did, I wrote a wrong value of moment, because this is a corner, a frame corner. Of course, these values of moments in the node, they have to be the same, right? So to correct it, I must input the same value. Yeah. But what happens, I get a unbalanced forces. Yeah, so the joint is not in equilibrium. So there has to be something wrong. So I switched to wireframe to check the structure model, how it looks like, and the distribution of the internal forces. And here I can see that actually here the forces that I apply were applied not in the node, but here at this point. Yeah. And why is it so? Because if I take a look at the model, I have these two beams, or the column and the beam, they are shifted by this value of 1116 millimeters. So since you shift it in the x, along the x-axis, you also shift the point where the forces are applied, because normally and usually you have 0 here. So that means that the member end lies right in the node, right here. But since I shifted it, I have to do something about shifting the forces as well. So there are two options how to correct it. First one is, if I switch to here, I would also shift the position of the forces of 1116 millimeters. How to do that? I go to the beam. Here I switch from forces applied in node to forces applied in position, and I input this exact value. Same I do here. And let's check it. Oh, that was has to be minus, of course. And this as well. Let me see the wireframe model. I get the somehow wrong value here. Oh, it's minus. Yeah. So we have to shift it not to the right by plus, but by minus to the left. So we get aligned it with the node position, right? So that's why it's minus. So minus this value, minus this value. I go to load effects. I have it in the equilibrium, all zeros, same values. So that's right. And that means that the shear forces and normal force is they're applied, they are constant along the beam, so they are applied actually on the node. And the moment value, this 32.1, lies right in the node. Yeah, and if I take a look, now the value at this point is 4.4, and so on, and so on, and continues with the linear simplification. So that's how you can do that. And another way would be just simply calculate. If I go back here and reset this modification, again I have this unbalanced forces. So if I just calculate the value, so that would be 32.1 minus 10.6 of a shear force multiplied by 1.116. Oh, sorry, I didn't put it in the braces, so I need to find a better function in my calculator. So 35.1 minus 10.6 multiplied by sorry, once again, minus 34 minus 32. Oh, it just doesn't communicate with me. Minus 32.1 plus now 10.6 Oh, sorry, I'm confusing two different beams. This is the right value. By 1.16. Okay, so the value is this one. So if I copy this, minus 4.42, and that was actually the value that you could see in the previous model. Oh, I got it confused. Let me open this this another model. I got somehow lost in the in the hand calculations. So if I go back here and I switch to the positions, I got the value of 4.4. That was what I calculated in the calculator, right? So that would be the same what I apply here. Yeah, so as you can see, it's much more comfortable if you use the first option by shifting the forces by position, then recalculating by hand. I believe you're more skilled with that than me, so you won't get lost. But still, this is for sure the easiest way. All right. So this is how you set and align the nodal forces in IDEA StatiCa, and in case you have any member shifted along x-axis and you have shear force that is generating a moment, you have to shift the position of forces as well, that you do here. All right. About the questions, I see Vit is already answering, or has already answered quite all of them. So let's jump back to the presentation, and if you have any more questions, just feel free to send them to us by email. We'll answer them as soon as we get to them. And after the webinar, I kindly ask you to fill out the short survey. And about the recording of this webinar, it's coming on the website tomorrow, so you can play it again. And if you're interested, you can get the trial version, of course, for free at our webpage, ideastatica.com. And things to remember, feel free to visit our resource center, which is on our webpage, ideastatica.com, where we store a lot of information, tutorials, and FAQs, and so on. And as well as the recorded webinars from past, from last year, this year, and so on. They are all stored there, as well as on our YouTube channel. And one last thing, we'll see you again, looking forward to 17th of October, which is in 2 weeks, and there will be another Day of Connection Wednesday webinar. So thank you for attending today's webinar, and yeah, have a nice day. See you in 2 weeks. Bye-bye.